So we're going to work through this problem together. So you should have a graphing calculator out handy. Notice I have my graphing calculator over here on the screen. And we're going to do this problem right here together. So we're going to write the equation and make the tables for each of these situations, A and B, and then sketch both of them onto this graph down below. So for A, in 1970, there were only 7 cars in a city in China, and for 30 years the number increased by 32% each year. This gives you a clue that it's exponential. It's increasing by a percentage each year, so it's going to go up more and more and more. So we're going to need an exponential equation. So I'm going to need my A, my starting amount, and my B, my base. And so my A, ooh, that was not a good A, is only 7. A is 7. So this virtual pencil is sort of hard to use, and I get better at it as I use it more. So that's an A. So it starts at 7, and B is my base. And remember, it's always adding or subtracting from 1 for a exponential equation. And since it's increasing, that means we're adding to 1. So it's going to be 1 plus 32%. So remember, percent just means out of 100 per 100. And so 32 divided by 100, which is 0.32. So it's 1 plus 0.32, or simplifying that to 1.32. So our base is bigger than 1 because it's increasing. So there's my A and my B, and now I can very easily make my equation, because y equals A times B to the x. So y equals A, 7, times B, which is 1.32 to the x, raised to the power of x. So make sure you make that x little guy up here on the top, so it's an exponent. So our exponent is the variable. So our next step is to enter that equation into our graphing calculator. So if you're not that familiar with graphing calculators, this is where you enter the equation. You hit the y equals button, brings you to this window right here. So we're going to type this equation in just like a typewriter, basically, just like a word processor. 7, and then there's your times, and then your B, 1.32, and this thing right here says raised to a power. So this, when I hit that key, it's going to give me a little place to put an exponent. And this is your variable key here. And so it's the default is x. You don't have to worry about any of these other variables. So just hit on this is x. So we have 1.32 to the x. Now we're going to go to the table. So to get to the table, we're going to hit second, because we want to get to the blue one here. So this graph is here, and the table is blue, and so we had to hit the second button to get to the table. Okay, so you'll notice that my table goes up by 5s conveniently. I want to show you how to do that. Normally, when you get to the table, it's going to start at 0, and it's going to go up by 1. So this is what your table probably looks like. So I should have had it set this way to begin with, but normally a table will go up by 1, so it might even do something different. But you have the power to change the table to make it anything that you want. So you'll notice right here, starting at 0, we're going up by 5, so we can put our 0 and our 5 in here. So obviously it starts at time 0. According to the equation, it starts at 7, so it starts with 7 cars. And then at time 5, we have 28 cars, round to the nearest whole car. We obviously can't have a fraction or a little tiny piece of a car. Okay, now, so our table, since it's going up by 1s, is sort of a pain, because we would have to scroll down, and it takes a long time, and we just want to go back to our handy-dandy table set function. Second window brings you to table set. So we're going to start at 0 again. So let's have it start at 0, and then have it go up by, instead of 1s, you can have it go up by 5s. Isn't that fun? So table set, start at 0, go up by 5s. I'm going to go back to the table, and now we have it the way I had it originally. So it's going up by 5s. So 28 and then 112. I got to get my pencil back. And then 450, rounded up to 451. Since it's 5 or above, you round up. So 451 at 15, 1805 at 20 years. So it's going up. See how it goes up slowly at first and then starts going faster and faster. At 25, we're already at over 7,000 cars. But look what happens at 30 years. It really shoots up. So at 30 years, it shoots all the way up to almost 30,000 cars. Okay, so 28,995. Forgive my email alerts. 28,995. So there we go. Ooh. So that's that first equation, shooting all the way up to almost 30,000. Now let's go ahead and enter our second equation. First we have to write it. So this is obviously linear. It's going up by the same amount each year. Our slope is going to be positive. It's increasing. So m, so it's an mx plus b. So in this case, m is 500, positive 500. And then b is the starting amount, the same as the other one, but it's also 7. So b is 7. And then, so y equals mx plus b. We get y equals 500x plus 7. So that's the equation we're going to use. And we're going to enter the second equation into the graphing calculator. Oh, that was bad. So notice I have a little eraser. Why did that happen? Okay, 500x. That was a really bad x. But you can do better than that. X plus 7. Oh, that's such a bad x. I'm going to get rid of it. Oops. I'm going to go 500x. Okay, plus 7. All right. So getting over into here, we're going to go back into the y equals, and we're going to enter our second equation. So 500x, x, and then plus 7. So we're going to go into our table. Notice how, remember, you have to use the second to get to table set or to table. So second table. So now I have the other one here. It starts at 7, and it's going to go up by 500 every year, or 2,500 every 5 years. So it's 2507 at 5 years. That 2 doesn't really look like it's not really a very good 2, but you know, put a little A on it. Okay, number at 10, so we're going to be at 5,007. So we're going up by 2,500 every year. 2,500 every 5 years. 500 every single year. And then it's a 10, and then 7,507, another 2,500. Oops, why did I put a 0 on that? Me bad. Okay, now I got to go back to my little eraser. See? And that erased too many things because this thing is sort of clumsy. 5, I remember there always has to be a 7 at the end. That's a pretty bad 0. Okay, 75, and then another 2,500, 10,007, obviously 10,007, and then 25 is 12507. And then finally, at 30 years, we're up to 15,007 cars. So it's increasing by a linear, steady amount every time, every 5 years, or every year. Okay, whew. So now we've got our tables filled out. So now we have to do the graph. So I gave you a graph with just the right number of boxes so they make your life easy. If you count the number of boxes here, well, the number of spaces, you will see that there are 30. I did that on purpose. And notice how it goes up to 28,995. So this is our y values right here. So for setting up our y-axis, which is the number of cars, we need to look at the range of values right here. So the range goes from 7 to almost 30,000, and this one goes up to 15,000. So that means I'm going to set my Y scale. So this is going to be 30,000 up here. Now this is going to be really pain for me to do, but you can do this much better than me. That's a 3, so 30,000. So 30,000 is my biggest number up at the top here. A better 3? Yeah. And so it's good to put these little marks on there because it helps. So every, by the way, this down here is 0. Always start at 0. So our number of cars, 0, and each one of these is going to be 1,000 up to 30,000. So 1, 2, 3, 4, 5. Remember, each, you have to make equal increments. Every space here is worth 1,000 because there's 30,000 up here. And there's 30 spaces, 30,000. So 1, 2, 3, this is going to be 5,000. That was a pretty bad 5. 5,000. And notice how I'm not going to put every, don't label every single space. That just clutters up your axis, and it's really hard for me to do with this pencil, but you shouldn't do it either. Just every 5 is good enough. 5, 6, 7, 8, 9. 5, 6, 7, 8, 9, 10. Here's 10. Oops. 11, 12. I'm so stickly here. Okay, so yeah. 5, 6, 7, 8, 9, 10. 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. See? So make scaling my axis. You didn't necessarily have to start with the Y, but that's the hardest one, so I started with the hardest one first. 10,000, 15,000, and then 20,000, 25,000, you should make your number smaller, because what you really need to do, you also need to label, you should label this axis as number of cars, and that's going to be really hard for me to write sideways with my virtual pen. So I'm just going to assume that you're going to do that. You write along here number of cars. So you're telling your audience what this graph represents, what these numbers represent. They represent the number of cars. But it's really hard for me to write small with this pencil thing, and that doesn't even look like a 2. So 25,000 and okay, that's good enough. Where you got the idea. 25,000, and so that's our y-axis. Number of cars. Make sure you've labeled it such. So down here, we've also got 30 spaces. Isn't that convenient? So that each one of these is going to be worth 1. 1, and so starting at 0, 1, 2, 3, 4, 5. 6, 7, 8, 9, 10. This is going to be years. 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. My 20 will go there. 21, 22, 23, 24, 25, and then 30. So here's 30. So this is going to be years, time in years. I can write this direction. It's a little bit easier, but I don't really want to try to I'll just make a big mess if I try to write sideways. Time in years. So time in years is your x-axis, and number of cars should be labeled on your y-axis. Time in years. Of course, you're going to be able to write better than me. Time in years. So we have 5, 10, 15, 20, and 25. So now you've got it labeled every 5 years, which is very handy because that's pretty much what your table is showing you. Then you're going to plot the points and draw a sketch in the curves. So let's do the exponential one first. Starts at 28,995. So if each of these is 1,000, this is going to be 25, 26, 27, 28 is going to be here. 29 is there. This is really close to 29. So so that's how high up you're going to end up going. So notice how that's a good That's why I scaled it that way. Anyways, we're going to start at 7, which is pretty much right down there. I'm going to change the color of my pencil because I can and because it's sort of fun. Okay, so we're going to start at just 7, which is really basically really close to the 0 since everything is worth 1,000. So there's my starting value. So that one's, and then 28. So at 5 years, it's only 28, which is still, since each of these is 1,000, it's really still pretty much just right, hardly even, it's still right down at the bottom. At 10, it's 112, which is still, since each of these is 1,000, it's still really, no, it hasn't really climbed very much at all. But when we get to 15, we are at 451, which is close to a half of 1,000. So you should be getting up right about to the half 1,000 there. Okay, so at 20, we're going to be at 1,805. So we're going to be 1,000, this is 2, and then 1,805, so that's about there. And then at 25, 7,235. So, now we're, it's 5, 6, 7. 7,000, it was going to be there, but it's at 7, so it's about a quarter of the way up. And then at 30, we're all the way up. Remember, this was 29, so we're really close to 29. So there's your exponential curve. I'm going to try to sketch it, and I'm probably going to make a mess. So you try to do a better job. But notice how it just starts off really flat, and then goes up, 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 fast, fast, fast. I really did a bad job there. This is really hard to do. But you should have a nice smooth curve. Notice how it goes up faster and faster and faster. Mine's really sloppy because I have to use this thing. I'm going to change the color now to, let's make it blue so I can do the linear one. Now the linear one is really a lot easier because it goes up by the same amount, but you're still going to start at 7. And then you're going to go, at 5 years, you're already at halfway up here. So it's 1, 2, 3, you're really right, so right about there. And you only really need to do, you don't necessarily even have to put in all the points for the linear because 2 points make a line. So at 10, you're going to have 7, you're going to be at right about at the middle here, and so on. So it should just be going up by the same linear amount. 10 is 5,000. So, yeah, and so basically you're going to have a line. If you put your ruler along that, you can just, should be a straight line. At 15, we're going to be at about 75. So being about the halfway point. At 20, we're going to be at 10, just a little bit above the 10,000 mark, so just really right a bit there, right? And then at 25, we're going to be at 25, we're going to be at right in the middle here, which is around there. So, yep. Whatever, I just lost my train of thought here. So 25, we're going to be at right in the middle here, so we're right there. Right there. And then at 30, we're going to be at 15,000. Yeah. So, yeah, so here's your linear one. Oh, so again, you have a ruler. I don't. So I am trying to make a straight line, but that should be a straight line. So you should end up looking something like that. So then the two situations are equal where the two graphs intersect. So it should be right around here, right around this, you notice in between 25 and 30 years, somewhere around 25 years, between 20 and 25 years, it should be, they cross. It goes from 20 to 125, from 18 to 72. So this one in between, so my graph is not really terribly, it's a little bit crooked, but so you need to figure out about where they cross. Okay, so that's about it. I think that, oh, you should circle, or you can, notice where the intersection point is right there. And that's about it. Thanks for watching.